Hi guys, welcome back to my CatMat tutorial channel. Danielle's here, and today, as promised, I'm making my first video in probability to give you the first practice for exam P. And my video today will be divided into two parts. The first part, I'm going to give you some lesson about how to set up sample spaces, how to define events, and how to calculate probability of an event. Then I will have some exercises, some problem set for you to practice on. So before I go to the lesson, I want to give you a very simple real life example to give you the first look to capture a picture of probability. So let's say warm-ups. Consider an experiment of tossing a fair coin twice. You don't need to know probability before to know what is the outcome of tossing a fair coin twice, right? So use your common sense. Obviously, we know the outcomes. We have four outcomes, right? Either head, mean head at the first time and head at the second time, or head tail, or tail head, or tail tail. So from this example, sample space is basically the list of all of these four outcomes. So we have sample space. It's just the list of these four outcomes. So it's the list of four ordered pair. The first one is head. We have head tail, tail head, or tail tail. And each of these four outcomes is called a sample point. So we have four sample points. Is either head or head tail, tail head, or tail tail. And also, when you look at here, suppose I ask you what is the chance of getting head at both times. So I have something called event. Event A is the chance is getting head at both time of tossing. So here, what is event A? Event A here is basically the collection of two sample points. The first one is head and getting head at both time of tossing. So event A here, we have only one sample point, right? Let's say event B is getting head at the first times of tossing. So we have B as a collection of two sample points, head and head tail, right? And one more, what if I ask you about an event of getting the same types, the same either head or tail at both time. So event C here is basically the list of two sample points, which are head or tail. So event here is basically just a collection of some sample points from the sample space. You see that? Here, from this example, I think you already know the basic concepts in probability. What is sample spaces? What is sample point? What is an event? So I'm gonna go ahead and give you the definition. So look at here. In the lesson today, I will talk about sample space, sample points, outcomes, event, union, intersection of event, mutually exclusive events and outcomes, complement of an event, partition of an event, De Morgan's law, indicator function for events. So from the first example, you already know the definition of sample space, right? So sample space is the list of all possible outcomes from an experiment, and sample point is a single outcome from the sample space. Sample space contractors. And what is outcome and events? We also have, from the first example, we already know what is an event, right? So an event is a collection of some sample points. Like from the first example, we know event A is the collection of only one sample point, which is head-head, that is represents for the event of getting head at both time. Event B is getting head at the first time, so we have two sample points, either head or head tail. So that is the definition for an event. Now we talk about union in intersection. So what is union? Union of events. Union of events let's say A and B, of event A and B is the event that either A or B occur. Either A or B occur. And intersection of event A and B is the event that both A and B occur and B occurs. So if you go back to the example that we did before, in this example, B unions, the union of A and B, the union of A and B is an event that A and B both either A or B occurs. So that is either getting head at both time tossing or getting head at the third time. So the union of A and B is basically just a collection of all sample points from A and B, right? So it's basically just head and head tail. The union of A and C, is basically just an event of either getting head at both time or getting the same either head or tail at both times. So we have head or tail, right? And the union of B and C is an event of either getting head at the first time of tossing or getting the same either head or tail at both times. So B and C union will be either a head or head tail or tail. You see that? So this is how you define the union event. And the intersection is basically just the event of both events to be occurs. So the intersection of A and B is what? A and B, we have one intersection, right? That is head-head. So that is one single point, one single point, head-head. And the intersection of A and C is also just head-head, right? Just head-head. You see that? So now we go back to the definition. And by notation, union of an event is notated by a notation that is union, and intersection is notated by these symbols. Intersection. You see that? So A and B union is notated by notation. Notation is A union would be A union B, and this represents for A or B. That means either A or B occurs. Intersection, the notation is A and B, right? A and B. A and B. And B. This is represent for A and B. By Venn diagram, I'm gonna make a picture here. So let's say this is A and this is B. So here the shaded area represent for the intersection, and everything formed from A and B, that is this area, is called A or B. So A or B is just the combine of A and B, and A and B is the shaded area. I'm gonna give you another example for you to understand better the intersection and the union. Suppose look at an apartment that you sharing with one of your friends. So let's say this is your room, bed space A, and your roommate's room, that is bed space B. In your apartment, in your shared apartment, you have the living room. So I'm gonna say this is the living room, and you have the kitchen. This is the kitchen and the laundry. So your area is anywhere in the apartment that you can go to. So in this apartment, you can go to your room, you can go to the living room, you can go to the kitchen, you can go to the laundry without asking for anyone permission. Your roommate can go to her room, which is the bed space B. She can go to living room, kitchen, and laundry without asking for your permission. But you cannot go to her room without her permission, and she cannot go to your room without your permission. So here, the intersection is the area that both you can work to without asking for anyone permission. And the intersection in this apartment is the living room, the kitchen, and the laundry. And the union of your area and your roomie's area is the whole apartment. You see that? I hope my example is easy to understand. So don't worry about this. I'm going to give you more example to practice. Next, what is mutually exclusive event and outcomes? So mutually exclusive event is basically two events that cannot occur at the same time. So go back. Mutually exclusive, mutually exclusive event. A and B are said to be mutually exclusive events of each other if A and B cannot occur at the same time. For example, if I choose one student from my class, suppose I'm a teacher and I choose one student from my class to go to attend an event, So let's say A is the event of getting a girl, a male student, and B is an event of getting a female student. So because you are choosing only one student to attend an event, there's no chance that you can choose both one male and one female student, right? So here A and B are the two mutually exclusive events to each other because A and B cannot occur at the same time. You see that? So that is mutually exclusive event. Also, we have another event called exhaustive event. So A and B are said to be exhaustive events to each other if A and B combine to be the whole sample space. You see that? So go back to the example of if I choose a student from my class to attend a musical event. So A is the event of getting a male student, and B is an event of getting a female student. So here, because suppose we don't have transgender, we don't have bisexual, so in a class we either have male or female, so we should have only two outcomes: either we get a male student or a female student. Here A and B are exhaustive events because when we combine them together we have the whole sample space. So here A and B are exhaustive events. You see that? But it doesn't mean that here, don't be confused. Mutually exclusive event doesn't mean to be exhaustive events. So because in this case I give you only two events, so by coincidence here A and B are both mutually exclusive event and exhaustive event, but I'm going to give you some other example later to separate the two. These two are different. I repeat, these two are different. Mutually exclusive events are not exhaustive events. Okay, so next, what is complements of an event. So let's say A, let A be an event. So a complement of event, the complement of event A, the complement of event A is an event indicating that A does not occur. So example, if I throw a dice, a 6-faced dice, let A be an event of getting number one on the face. So the complement of this event is the event of getting any number, not number one. That is not number one. You see that? So and usually complements of event is notated by the complements of event A is notated by AC. Let me include some. Okay, so the notation for the complement event is either AC or A prime. So I want you to learn the notation here. On the exam, sometimes they usually on exam P they use A prime. It's very rare that they use AC. So learn this notation. You see that A prime represents for the complements of an event. You see that? So that about complement of an event. Now we go to partition of an event. So let's say let A be an event. Let A be an event. A series of events A1, A2 to AN is called a partition of event A if and only if we have two properties here. First, if and only if the union, if A1 union with A2 union with A3 union union to AN is A, and A1 and A1, A2, AN are mutually exclusive. By the way, another terminology to describe mutually exclusive event is disjoint events. So you really need to know all of the terminologies, because on the exam sometimes it said A and B are mutually exclusive. Sometimes they just say A and B are disjoint events. So you really need to get used to the terminology. Next, De Morgan's law. De Morgan's law. So the De Morgan law say that the De Morgan law say that A union B, the whole thing complement, will be equal to A complement intersect with B complement. So here's the rule. A, the complement of A is A prime. The complement of B is B prime. And the complement of union is just basically intersection. Similarly, we have A intersect B whole complement is equal to A complement union with B complement. So this is about the De Morgan's law. The last thing in sample spaces and event is indicator function. So the definition of indicator function. An indicator function of an event A is notated by IA of X. IA of X. And this function would be either so let me move down a little bit. Okay, so IA of X equal to 1 if X belong to A, and is equal to 0 if otherwise. That means X is not belong in A. Not belong in A's. Not belong in A. I cannot find the not belong notation here. So I'm gonna just simply say X not in A. Not in A. See that? So that is indicator function. So I have finished the sample spaces and event. Now I'm gonna talk about probability. So what is probability? Definition: probability is the chance of something happening. And notation is, suppose we have PA is representing for probability of A. So this is probability of event A. That means the chance that A occurs. The chance that A occurs. So you know that for example, if you playing a lottery game, example, if you are playing a lottery game, and if I say you have 50% chance of winning, and A is the event, that you win. So here you have probability of A should be equal to 0.5. You see that? And one thing you observe in here is that probability they should be between 0 and 1, right? So now we go over some properties. Property of probability. So let's consider a sample space of n sample points. A1, A2, A3 to AN. So remember, each sample point can also be an event. So we have two probability here, probability properties here. We have probability 0 less than or equal to probability of AI and less than or equal to 1 for all I. And the sum of probability of all of these events should be equal to 1. That is two properties of probability. And in probability, we have some common use rules. The first rule is probability of sample space. Is 1. By the way, I want you to learn one more notation. Omega here is representing for the sample space. And we have probability of an empty set. An empty set is 0. Empty set is 0. Next, if A1, A2, .an are mutually exclusive. That means like none of these events occur at the same time. So if A1, A2 to AN are mutually exclusive, we have one more property, that is the sum of probability of AI is exactly probability of the union of AI. Union means the union of all of these events. So that's one more probability. And the last, also very important rule, is additional rules. So let's A and B are two events. Where is my... Okay. Let's A and B are two events. Let's A and B are two events. We have the additional rule is probability of A or B is equal to probability of A plus probability of B minus probability of A and B. This is the additional rules. And for three events, let's A, B, and C are 3 events. Usually on exam P, we should have only 2 events and 3 events. So for 3 events, we have probability of A or B or C, probability of A or B or C is equal to probability of A plus probability of B plus probability of C minus probability of A and B minus probability of A and C minus probability of B and C and plus probability of A and B and C. So here's the hint, here's a tip to for 2 events it's easy to memorize. However, many people got difficulty remembering the formula for additional rule for 3 events. So here's a hint. You see that probability of A, probability of B, and probability of C go with positive side. I mean plus. Probability of A and B, probability of A and C, and probability of B and C go with negative side, which is minus. And probability of A and B and C go with positive side. You see that? So here's a tip. If the event has only 1 letter or 3 letter, I mean odd number of letters, the sign is positive. If the event has an even number of letters, the sign is negative. You see that? For example, probability of A and B, we have 2 letters. 2 is an even number, that's why it's negative. Probability of A and B and C, A, B, and C are 3 letters. So the number of letters is odd, that's why the sign is plus. So the additional rules, I don't want to give you the proof here because it's going to be very long. But these 2 additional rules can be proved by using Venn diagram. So you see that. So here I have finished the lesson for the first topic. So the first topic is I have go over sample spaces, event, some common rules, indicator function, probability, and now what I'm gonna do is I'm gonna go over some exercise to help you practice for exam. So let's look at some exercise. Today I'm gonna give you 5 exercise, 5 assignments. So first, problem number 1. A survey of 1,000 people determines that 80% like walking and 60% like biking, and all like at least 1 of 2 activities. What is the probability that randomly chosen person in this survey likes biking but not walking? You see that, like biking but not walking. So we have 5 answer choices here, either 0, 0.1, 0.2, 0.3, or 0.4. Here is one advice for you when you work on probability. I want you to first don't do anything, just look at the question, read the question carefully, and pick up information. So when you pick up information and convert the problem into notation, mathematical notation, that process I call mathematical modeling. So if you know how to modeling of problems, you're going to solve the problem easier. So here they said 1,000 people determines that 80% like walking, 80% like walking, and 60% like biking. Some people ask me some question that why 80% and 60% when you add them together is not 100%. You know, like when I tutor some student, they ask me this question. So here's the reason, because for people who like walking, they might also like biking. And for people who like biking, they might also like walking. That's why walking and biking are not mutually exclusive events. That's why the probability of them combined together is not 100%, it's over 100%. You see that 80% and 60%, if you add them together, is 140%, is more than 100%. So here, I'm gonna give you two approaches. The first approaches, I'm gonna use exactly the definition, notation, and the theorem that we have learned. So here we have, I'm gonna say, you know what, like when you work on a problem, how you set up notation is also very, very important, because it's not gonna get you confused when you work over the problems. So here, let W and L represent the event that are randomly the events that a randomly chosen person, like walking and biking respectively. That means W is the event that a randomly chosen person like walking, and L represents for event that a randomly chosen person like biking. You know, sometimes you might use notation A and B, it doesn't matter, but here I use W and L because it's not gonna get me confused. Whenever I look at W is the first letter of walking and L is the first letter of biking. So I never get confused what is biking and what is walking. Now, when I already have the notation for this problem, I'm gonna pick up information. So the problem said 80% like walking, so I write out very quickly. Probability of W is 0.8 and probability of L is 0.6. You see that, because it said 80% like walking and 60% like biking. So, and don't forget one more information. They said like all likes at least one of the two activity. So you have one more information, that is probability of W or L's equal to 1. You see that, because they said like at least one, so any people here among 1,000 people either like walking or L. That's why probability of W or L is 1. You see that? So now the question asks you, what is the probability that a randomly chosen person in this survey like biking but not walking? So the probability that a randomly chosen person to like biking but not walking is probability that of B. That means I shouldn't use L, right? I should use B, mean biking. I'm sorry about that. So probably B, not L, but B. And W and B, yeah, B. So the probability of biking minus the probability of biking and walking. Do you see that? Because the question asks for the probability that a person like biking but not walking. So basically you take the group of people who like biking and subtract the group of people who like biking and also like walking. You have the group of people who like biking but not walking. You see that? So here what you have to do, probability B is already given. You need to find probability B and W to find the answer. So don't forget the additional rules here. By additional rule, we have what? Probability of A and B. Probability of A. Actually, we have probability of A or B equal to what? Probability of B plus probability of walking minus probability of B and W. So right, probability B or W is given. Probability B is also given. Probability of W is also given, and we need to find probability of B and W, right? So we have here probability of walking is 1 equal to 0.6 plus 0.8 minus probability of B and W. See that? So from here we have probability of B and W is what? Is 0.6 plus 0.8 minus 1, and that is 0.4, right? So now we have probability of B and W, and the question asks for the probability of a randomly chosen person like biking but not walking. So answer is we take probability of B, which is 0.6 minus 0.4, and we have that is 0.2. You see that? So hence we have conclusion. We have conclusion. The probability that a randomly chosen person likes biking but not walking is 0.2. You see that? Or 20%. You see that? Or 20%. So this is the first approach. Like basically use what we have learned. Another approach is, so that is the first solution. Another approach, another way is I'm gonna set up using this way. Is actually like in biology you're gonna see it look pretty much like biology. So I'm gonna let the BW represent BW's mean like both biking and walking. B capital B little W represent for like biking but does not like walking. We also have WB BW mean like walking but does not like biking, and B little W mean little b little W, so BW mean like neither. That means doesn't like biking and doesn't like walking, like neither. You see that? So here the second approach I use completely different notation. That's why you have to reset up the problems. The question give you that 80% like walking, so the because 80% like walking, here 80% likes walking, 80% like walkings. I have so many typos. 80% like walking, that mean you have BW plus little b big W is 0.8. You see that? That means like you collect anything that go with capital W, combine them together is 0.8, and 60% like biking, So we have B capital W plus capital B little w is 0.6. You see that? And they said like all of these like at least one, like all like at least one of at least one of those two activities. That mean little b little w is 0, because like no one likes nothing, right? So BW is 0. And one more thing, don't forget that the probability of all possible outcome is 1. So we have BW plus B little w plus W little b capital W plus little b little w is 1, right? So here what do we have? We have BW is 1. So we have BW plus capital B little w plus B capital W is 1 because little b little w is 0, right? So now we have three equations. BW plus BW capital B capital W plus little b capital W is 0.8. You see that? So read the question again. They said like, what is the probability a randomly chosen person lies biking but not walking? That means the question asks for lie biking but not walking. So little w capital B. You see that? Little w capital B, or it's like capital B little w, and it's from the second equation right here. Do you see that? So if I subtract this equation, the third equation, to the first equation, I have little bw. I have capital BW, right? So this is equal to what? This is equal to 1 minus 0.8, and that is 0.2. You see that? That is 0.2. You see that? So now I have finished the first problems. Now let's take a look back. So the first solution is basically just use additional rule, and the second solution, I work pretty much like biology. For people who work on gender, we do this problem a lot, right? So that is the first problem. Now we go to the second example. Problem number 2, SOA. Here I have the word SOA. That means this problem has already been given in the old exam, the actual exam. Among a large group of patients recovering from shoulder injuries, it is found that 22% visit both a physical therapist and a chiropractor, whereas 12% visit neither of these. The probability that a patient visit a chiropractor exists by 0.14. The probability of a patient visit a physical therapist determine the probability that a randomly chosen member of this group visits a physical therapist. So for this problem, the same. We're gonna have two approaches. Like either you set up only two letters for two events, or you set up the group with capital and little letters. So here I'm gonna go by the second approach. So let's P PC P little c little p capital C and PC be the four possible events, or four possible events. You again, like capital mean for example, capital P capital C mean like visit both physical therapists and chiropractors. You see that? So don't forget that PC plus capital B little c plus little b capital C plus little b little c is 1. Now we read the question again to collect information. It is said that it is found that 22% visit both. So we have capital B capital C is 0.22. You see that? 0.22. Next, whereas 12% visit neither. Visit neither mean not physical therapists and not chiropractors. So we have little b little c is 0.12. You see that? And they said that the probability that a patient visit a chiropractor exists by 0.14. The probability of a patient visit a physical therapist. So look at here. The probability that people visit chiropractors mean either capital B capital C or little b capital C, and this is this 1.14, so that equal to 1.14 plus probability that a patient visits physical therapist So it's PC plus P literacy. You see that? So from this equation, capital P and capital C cancel. So we have little p capital C equal to 0.14 plus capital P literacy. So now what do we have here? We have the first equation, probably capital P capital C plus capital P little c plus little p capital C plus little p little c is 1. Capital P capital C is 0.22, little p little c is 0.12. So from the first two lines, what I have here is what? I have capital B little c plus little p capital C is 1 minus 0.22 minus 0.12, and that is what? That is, by the way, for exam P, you cannot use any other calculator except the TI-30XS multiviews and some other. You can look for what type calculators is allowed to bring to the test room. Here I use TI-30XS. So 1 minus 0.22 minus 0.12, that is 0.66. So, and from the last line, we have little b capital C is 0.14 plus capital B capital C. So what we have here is capital P little c equal plus 1.14 plus capital B little c is 0.66. So from here we have capital B little c is 0.66 minus from 0.14 divided by 2, right? So 0.66 minus 0.14 divided by 2, and that is what? Minus 0.14 and divided by 2, that is 0.26. Now read the question again. They said determine the probability a randomly chosen member of this group visit a physical therapist. So hold up. So here I have PC. I'm gonna rewrite everything I have found. So capital P capital C is 0.22. Little b little c is 0.12. Capital B little c is 0.26, and little b capital C is 0.14 plus 0.26, right? That is 0.26 plus 0.14, and that's equal to 0.4. Yeah, that's equal to 0.4. Let me check again. So 0.22 plus 0.12 plus 0.26 plus 0.4. That's the one. Yeah. And the question asks for the probability that the probability that a randomly chosen person visits physical therapist. So this is equal to probability that is PC plus capital B little c. So this is equal to 0.22 plus 0.26. You see that? And that is 0.48. You see that? So the answer is D. See that? The answer is D. Answer D. You see that? Let's go back to the first problem. I got 20%. So that is C. You see that? Answer C. That's the answer C. Answer C. You see that? So I have done 2 examples. Now I'm gonna work on 3 more examples. Now look at this problem. SOA, an urn contains 10 balls for red and 6 blue. A second urn contains 16 red balls and an unknown number of blue balls. A single ball is drawn randomly from each urn. The probability that both balls are the same color is 44. The same color is 44. Calculate the number of balls in the second urn. So here this question is asking you to find the number of bars. So for sure, first you have to let X be the number of bars contained in the second urn. So a single bar is drawn randomly from each urn, and the probability that both bars are the same color is 0.44. So here, the same colors here, we can either have the same color red or the same color blue, right? So I'm have first, what is the probability that we have red in, I'm gonna call R1, representing for R1, and B1, B, the probability, or be the event of getting red. Let's say R1 is the event of getting red from the first urn. R2 is the event of getting red from the second urn. So what is probability of R1? Probability of R1 is, you see here in the first urn we have 4 red and 6 blue. So the probability of getting a red ball is 4 out of 10, right? 4 out of 10, and that is 0.4. And the probability of getting red at the second urn is, we have 16 red ball and X blue ball, so it's 16 over. So let me set up a equation here. We have 16 over 16 plus X. That is the probability of R2. This is the probability of R2. And so from here, the probability that getting red at both urn, the probability of getting both red from both urn is, which this kind multiply these two together, so it's 0.4 times with this is time with 0.4 time with 0.4. Similarly, if I say B1 is the event of getting blue from the first urn, we have probability of B1 is 6 out of 10, right? That is 6 out of 10, 6 over 10, that is 0.6. And B2 is the event of getting blue from, I'm sorry, the second urn. So we have probability of B2 is what? That is in second urn we have X blue bar, so X over 16 plus X. You see that? So from here we have the probability of getting both blue from both urn is, which is kind of like multiplication rule. So this is X over 16 plus X times with 0.6. So from D2, I'm a color D2 for you to see it better. So we are going to add the two together to have the probability of getting the same color. So the probability of getting the same color from two urns is just adding the two together, right? Adding the two together. So we have 16 times 0.4 over 16 plus x whole over 16 plus x equal to, I'm sorry, plus x times 0.6 over 16 plus x, right? And don't forget this is 0.44. So we are going to solve for x because that is what the question wants you to do. So we have 16 times 0.4 is 6.4 plus 0.6x over 16 plus x equal to 0.44. And from here we have 6.4 plus 0.6x equal to 0.44 times 16 plus x. So solve this equation. We have 6.4 minus 0.44 times 16. 0.44 times 16 is 7.04 equal to 0.44 minus 0.6x. So x equal to, we have 6.4 minus 7.04 divided by 0.44 minus 0.6, and you got x is 4. So x is 4. Therefore, we have conclusion. There are, if you found out the answer is not a whole number, there must be something wrong you did in your solution. So there are 4 blue balls from the second urn, in the second urn. Okay, so that is problem number 3. So let's look at the answer key. So the answer is A. You see the answer is A. So the answer is A. Answer A. Now let's look at the next problem. Problem number 4. You are given probability of A union B is 0.7. Probability of A union with B prime is 0.9. Determine probability of A. Before I work on this problem, I want to give you one thing maybe you didn't know. That is probability of A, B plus probability of A, B prime equal to probability of A. Many of you might not know about this. You know what? Probability of A, B means probability of A and B. Probability of A, B prime means probability of A and B prime. So don't forget that B prime is a complement, the complement event of B. You can understand this problem like, let's say A is representing for boy and B represent for light pink color, and B prime mean doesn't like pink color. So the group of men divided into 2 groups, the men who like pink color and the men who doesn't like pink color. So AB here represent for the group of male that likes pink color, and AB prime mean the boy, the male that doesn't like pink color. So AB and AB prime together is basically to the group of male, of boys. So that's why probability of AB plus probability of AB prime equal to probability of A. So to find probability of A, basically you need to find probability of AB and probability of AB prime. Here the question gives you A union B, that means A or B, A or B. So I'm going to rewrite these information. So 0.7 equal to probability of A union would be, I'm going to say A or B, right? A or B. And by additional rule, that is just probability A plus probability B minus probability AB. You see that? So from here, that is the first equation. Now look at the second information. We have 0.9 is probability A or B prime. B prime. So that equal to probability A plus probability B prime minus probability AB prime. So here if you add side by side, what do you have here? Probability A with probability A would be 2 probability A. Probability B with probability B prime is 1 because B and B prime are complement events. Probability AB and probability AB prime should be probability A. So probably if you add side by side these two equations, you will have one single equation of only probability A and you will be able to find probability A. So if you add side by side, you have 1.6 is 2 probability A plus probability B plus probability B prime minus probability AB plus probability AB prime. You see that here? Let me change the brackets. So we have probability A, no, probability B plus probability B prime. See that? So from here, we have what? We have 1.6 equal to 2 probability of A plus, don't forget that B and B prime are complements of each other. So probability B plus probability B prime is just 1 minus, again, here I have already indicated that probability AB plus probability AB prime is probability A. So this is just probability A. So we have 1.6 is 2 probability of A minus 1 probability of A is probability of A plus 1. So here we have probability of A is 1 minus 1, 1.6 minus 1, which is 0.6, and the answer is D. So we have answer D. See that? Answer D. Answer D. So you have answer D. Okay, so that is problem number 4. Now I'm going to talk about the last problem of today. That is problem number 5. A survey of a group reviewing habits over the last year reviewed the following information. 28% watched gymnastics, 29% watched baseball, 19% watched soccer, 14% watched gymnastics and baseball, 12% watched baseball and soccer, 10% watched gymnastics and soccer, 8% watched all of these. Calculated the percentage of the group that watched none of the 3 sports during the last year. So here I'm going to work directly from the question. Gymnastics, I'm going to say that is G. Baseball is B. Soccer, I'm going to use C. You see it? So this is C. Oh, what happened here? C. Okay. And gymnastics and baseball is G and B. Baseball and soccer is B and C. Gymnastics and soccer is G and S. All of these mean G and S and B and S. So again, this question asks for the group that watched none of these 3 sports. We have 2 approaches. The first approach, we have probability that none of 3 sports, 3 spots equal to 1 minus probability of either G or B or C. You see that? And don't forget the additional rule. we have probability of G or B or C is probability of B of G plus probability of B plus probability of C minus probability of G and B minus probability of G and C minus probability of B and C and plus probability of G and B and C. You see that? So this is probability of G or B or C equal to probability of G is, they said, like 28%, so that is 0.28. So we have 0.28 plus, and we have 29 watch baseball, so plus 29 plus 0.19 minus 0.14 minus 0.12 minus 0.10 and plus 0.08. You see that? So that's equal to 0.28 plus 0.29 plus 0.19 plus 0.14 plus 0.12. Oh, I got some mistake here. 0.28 plus 0.29 plus 0.19 minus 0.14 minus 0.12 minus 0.10 and plus 0.08, and I got 0.48. But that's not the answer yet. The question asks for the probability that none of these three spots. So that is 1 minus 0.48, and that is 0.52. 0.52. So that is the answer D. You see that? That is D. So answer D. So we have this is answer D. See the answer D. Another approach, just like what I set up before, we have but actually in this case it's gonna be longer, so I think I would like to finish here. So thank you so much for watching. That is my first lesson in probability, and I will continue to work on conditional probability and independence events next week on Monday. But don't forget, I have one more video on Wednesday about financial mathematics. Thank you so much, and I hope you guys enjoy. I know like this video might not be an interest to many people, but I believe some people really need this help if you are serious in taking exam P. So don't forget to look for my next video on next Monday. If you like my video, feel free to please give me a thumb up. If you don't like my video, just feel free to give a thumb down. Please subscribe my channel if you feel this channel helpful. Thank you. Bye bye.